Welcome to today's training session. In this episode, we are going to continue with the soil loss estimation using the universal soil loss equation model in ArcGIS Pro. In the first video, we calculated for the rainfall erosivity and soil erodibility of USLE equation. In this video, we will calculate for the other three. And for the other three, the first component is the topographic factor, which is the LS. So let's say something small about the topographic factor. It consists of slope length and slope steepness, which is S and L. Increase in the slope length causes increase in erosion due to a progressive accumulation of runoff in the direction of downslope. Increase in slope steepness factor S increase the soil erosion as a result of increasing velocity. We have the formula for the slope length, slope steepness. So for the slope length, we have this formula. In order to calculate for the topographic factor, we have to get the slope length and the slope steepness. So these are the formulas for calculating for the topographic factor. And finally, for the topographic factor, we have the slope length multiplying the slope steepness divided by 100. Now let's go back to the ArcGIS Pro. The next thing we have to do here is to add our DEM data. We have our DEM data here. So we have to drag and put it here, the map. So let me do that. So this is the result you are going to get after you do that. This is my DEM data for this project. After you added your DEM data, you need to extract the raster within the study area. So we extract by mask, go to geoprocessing tool, come to extract by mask. That's it. So for the input raster, we choose the DEM data. The feature mask data, we choose the area of interest, which is the area district. Then you click on run. After clicking on the run, this is the results you are going to get. Let me pull it here. Let me zoom to layer. So this is the results we are going to get after extracting the raster within the area of interest. Our next thing is to work with the raster data. Working with the raster data, you first have to fill the sink in the raster data. So that one, you go to your geoprocessing tool, type fill sink, go to fill, input surface raster will be the TCDM, then you run. So after running, we are going to get fill DEM. Let me uncheck this. You get your fill TCDM2. Now you have to run your flow direction. You go to the same geoprocessing tool to type flow direction. So the input surface raster will be the fill TCDM2. We will not change anything here. So on default, you run. And after running, we are going to get this result. The next thing we have to do is to find our flow accumulation. And for the flow accumulation, you go to the same geoprocessing tool, type flow accumulation. Choose input flow direction raster. We choose the flow direction, which is the flow DR1. I think we don't choose anything again. Then we run it. After running it, this is the result we are going to get. Flow accumulation, flow 1. So let me untick the flow direction. Yeah. So we now have the flow accumulation. Yeah. So we can now calculate for the slope length, and later calculate for the slope steepness. Yeah. We have the formula for calculating for the slope length. I think we have it here. Show it. Yeah. So the first one is the formula for calculating for the L, which is the slope length. So we can either, if you have it in a Word, you can copy it, and then so we go to geoprocessing tool, then we go to raster calculator. Click on it. Yeah, we come here. So we input the formula over here, which is the formula is we searching for the operators. You can find power over here. We double click. Then here you input flow accumulation. Flow accumulation. Flow accumulation times 30. We are choosing 30 because the size of the DEM is almost as 30. 0.5 bracket close. So this is the formula for calculating for the slope length. Then we can change the name to L because we are calculating for the slope length. And you click on run. After clicking on the run, This is the results we are going to get. This is it. So this is the result for the slope length. The next thing we have to do is to calculate for the slope steepness. But within the slope steepness formula, we have slope percentage in the formula. In order to get the steepness, we first have to calculate for the slope in the formula before we'll be able to calculate for the whole slope steepness. We are using the same process, raster calculator. We come here, then we sign. So we can find the sign here, double click. So we have the slope. So let's first calculate for the slope. So to calculate for the slope, we go to the geoprocessing tool, we type slope. So we have two slopes here. You don't have to choose the 3D analysis tools, choose the spatial analysis tools. Second one. So input raster, you choose the fill CC dim. Then for output measurement, you choose percentage rise, not degree. You run it. So you then run it. And after running, you get this result. Yeah. Get this result. So now we have our slope. We can now calculate for the slope steepness. So let's go to raster calculator again. Later, we choose the spatial analysis tool. We type in the formula, so you choose power. Choose sign. Sign. Then we can choose the slope we calculated. This is the slope fill. Slope fill down times 0.01745 plus 0.09 1.3 bracket close. So you can check the formula again and see whether everything is correct. So we have two brackets here. The only thing we have to do here. So add another bracket. So after running this, you click on run. After running it, we are going to get the slope steepness. This is the result for the slope steepness. Now we have the slope length and the slope steepness. Our next move is to calculate for the topographic factor, which is the LS. So we go to the same raster calculator. Let's clear this. Let's check the formula once again. So we have L into bracket L times S divided by 100. We have double click L to bracket times S bracket close divided by 100. We click here to check whether there is no error. Then you can change the name to whatever description you can understand. Then click on run. After clicking on run, you are going to get the results for LS. This is the results for. Sorry for my network. Then it's not loading well. This is the results for the LS. Now our next move is to, so we have our LS now. The next thing to calculate is our C, which is the crop management practice. Our C. So before we do that, we have to get a land cover land use data. And in this tutorial, we used the Sentinel-2 land use the land cover data. We now load our land use land cover data. Now load it. So there's it. So I click and drag into the map, and the results I will get is this. Yeah, so this is my Sentinel. This is my Sentinel-2 land use land cover data. Bring yeah. So our next thing is to extract the raster within the district. So we go to the processing. Go to the processing. We come to extract by mask. Choose extract. Choose the extract by mask. Yeah, then the input is the land use land cover. Yeah, there's it. Then you choose the district. Yeah, so after running this, we will get this result. We get this result. Yeah. Yeah. So this is the results we are going to get. Yeah. Mm, so let's go to, so we have the map classes here. So let me uncheck the land use cover. Return to layer. Yeah, so we have we have this Excel data. So here, yeah. So we got this from the attributes table. Yeah, we first have to copy first have to copy the attribute data from the land use land cover extracts to the Excel sheet. But first of all, we have to convert it to a polygon before we can copy those attribute table information. So we go to, just as we did, we go to geoprocessing, go to raster to polygon, start to polygon. So we choose this and we leave it like that, default, and we run. After running, we're going to get this result. We're going to get this result. Yeah, so now we can go to the attributes table and copy all those information. Yeah, so these are the information. We have the grid code, we have the shape, length, area, we have object ID. So what you have to do is to copy, Control A, copy, and go to an Excel sheet and paste it here. So after pasting it here, the next thing you have to do is to filter. Then we go to filter. Okay, I was already having it. So we go to filter. Control A to select all of them. Then we will come here to filter. I don't know why this is changing. Yeah. So after you filtered, you will see these drop downs over here. So we are going to assign the mapping unit in the grid code. Yeah, so you see we have this when you come here, so you can see we have when you come to the LTC, let me check the attribute table for this. Yeah, so the value we have here and the count is the corresponding pixels. Yeah, corresponding pixels. So this is the value, this is the grid code values we see in the Excel sheet, which is 1 to 11. These are the classes that that the data obtains. So we have 1 to 11 over here. So we are going to assign each of them to the pixels. So we go to the Excel sheet, we come to the grid code, click, deselect them. So when you click on 1, then you click OK. Then you come to C over here. Then you edit here. Then you input the value. By doing this, you have to use the classes table. So you can, as you can see over here, we have 1 for water, 2 for trees, 3 for grass, flat vegetation is 4, 5 crops, 6 shrubs, 7 built area, we have 8 for bare ground, we have 9 for snow, ice, we have 10 for clouds. So when you choose 1 in the grid code, then you type 0 over here because we have 0 in the C value. So we are done with 1. Now we go to 2. Click on OK. So these are these are the 2 values. So I've chosen 2 in the grid code. I come to C. We have trees, which is 0.025. So I type C over here. I type 0.05. Type 0.05 here. Then I double click on this and it will copy throughout. So I'll do same for all the classes. Yeah. So after you are done, you come here, you select all, click OK. And you see the numbers being arranged among each class. So let us go back to our ArcGIS Pro. So we come here. The next thing we do, let me clear this. So the next thing we will do is to copy the data over here. Do it. So you click on Shift plus down. Okay, so you copy, just copy all the values in C to the down, values in C to the down, you copy all of them. Then you come to C, you double click here, come here, you right click, then you paste. When you paste, it will align with all the grid code, all the IDs in the attribute table. As you can see, you have 0, they are all mixed here. Yeah. So when you are done, close it, close the attribute table. Then now we have to convert it back to the raster. So you go to geoprocessing tool again, go to polygon to raster, choose raster T, raster extract 1. Then the value field, we change it to C. This time we change it to C. Then you click on run. After clicking on the run, this will be your results. Yes. So this will be your results. So now let's say we have, let me do the alignment so you can see it well. So we have our C, we have our LS, we have the TCK. These are the components in the formula. So I'm just aligning all of them for the calculation to be very simpler. And we have our extract TC rainfall. Yes. So these are the 4 components in the formula which are needed to calculate for the average annual soil loss. So before we can do the average annual soil loss, we have to resample all the components. So to do that, we go to the geoprocessing, click resample. Yeah. So for the resample, I choose. Let me start with C. Yeah. So for here, the cell size, we choose 30, 30, 30, 30. We leave it like this. Then we click on run. Then we click on run. So after clicking on the run, we are going to get this. This is what you are going to get for C. So you would have to do that for LS. Do the same process for LS. When you do for LS, you get this. This is what you get. When you do for TCK, this is what you get. When you do for rainfall, this is what you get. Yeah. So after getting all this, we now have to calculate for the average annual soil loss. So let's get back to the formula for it to be clearer. So we have the rainfall plus the topographic LS plus the K, which is the soil erodibility. We have the C, crop management, and we have the practice support, which is equal to 1. So it's not going to affect the 4 components. So let's go to raster calculator, the geoprocessing tool. Processing tool. Yeah, so we have our component over here. So we have rainfall, the rainfall erosivity, double click, times soil erodibility, double click, times the topographic factor, times the last but not the least, you have the crop management factor. So after you've gotten this, you click on run, and you click on the run. This will be your results. Yeah. So let's get back to after you've gotten this, you need to assign the mapping unit, the classes, which we have a table, that guys, a standard table that we use to so this is the soil loss. We have the very low erosion, the low erosion, medium erosion, we have the high erosion, extreme erosion. So we are going to use this in the ArcGIS Pro. So we have our symbology. We have our symbology here. So we are going to change the upper values according to the table. So there is the Pro, and this is the table. So come to the symbology. So here, as you can see, it has already been changed. So the values seen here were the mapping unit. So when you check the value here and the value is within 0 to 1 or less than 1, then you type it here. When it's 5, type it. When it's less than 5, type it. So you do this upper value, you prepare this upper value according to this table. And you can see when you have 0 to 1, it's very low. So you change the label to very low. When you have low, L. When you have medium, M. When you have high erosion, so we do this, and then we change the color scheme to green, to a very greenish and plantation kind of data. So after you are done, I think you get this as your final results. So now, thank you very much for this training session again, and we hope you subscribe to our channel to get upcoming videos. Thank you.